Hi, good afternoon. Maayong adlaw ninyo guys. And here I am again. I am doing this video to help other people here who have been struggling um, in mathematics. So I received a question from James Mascarenhas, who happens to be my students before. I was his pre-calculus teacher and his basic calculus teacher during senior high school. And I hope these problems that I am going to solve will help him to somehow make himself a better solver of math. So here we're going to start to answer number one. We're going to try to evaluate the oops, what was okay, the the limits of pi minus 2x over sine x minus pi over 2 as x approaches to pi over 2. Okay, first thing that we're going to do, guys, we're going to do a test. We're going to try to substitute the value of x to the x variable in the function, and we're going to evaluate it. So if we were to do that, we're going to have this. Oops, we're going to have this. This is pi minus 2 times pi over 2 over sine pi over 2 minus pi over 2. If we're going to simplify this, you know that 2 will be canceled out. So what is left here, it's going to be pi minus pi. And the denominator becomes sine 0. Pi minus pi is, it's 0. And sine 0, it's also 0. Why did I know this? Because you just actually can use your calculator to evaluate sine 0. But if you want to know the reason, use the SOHCAHTOA concept using the right triangle. It's sine 0. So, yeah, sine 0 is 0, is equal to 0. And as you can see here, you are seeing what we call a term what we called indeterminate limit. If you see structure like this, and we are not going to allow that to happen because any value or any variable value divided by 0, the answer is actually undefined. In other words, it doesn't exist. Sama sa iyahang gugma nimo. Wala ni exist. Kasad. Relatable, right? However, for it to exist, we need to do something. Sama sa relasyon. For you or to make someone to fall in love with you, you need to do something else. You need to perhaps win his or her heart. So in this problem here, we're gonna do something that would make the function or that would make the limit exist. So what we're going to apply here is I'm going to change the color. What we call L'Hopital's rule. L'Hopital's rule. L'Hopital's rule is a method to evaluate limit if you see like this or indeterminate form. So what we're going to do is we're going to take the derivative of the numerator, which is pi minus 2x, and the derivative of the denominator, which is sine x minus pi over 2. Okay? All right, so now, after getting the derivatives of the numerator and the denominator, that's when the time that we're going to evaluate the limits. So here, the derivative of the numerator is just negative 2 because pi is a constant and derivative of a constant is actually 0 and derivative of negative 2x is negative 2. The derivative of sine x minus pi over 2 is actually cosine x minus pi over 2 times the derivative inside the parentheses. So that's 1 only because, this is a constant and a derivative of a constant is 0 and derivative of 1, I'm sorry, derivative of x is just 1. The technique here is you need to get the derivative first of the outer part of the function, which is the sine x minus pi over 2. So you need to solve for the derivative of sine, which is cosine, and you copy the terms inside the parentheses, and then multiply it to the terms or to the derivative of the terms inside the parentheses. So here. That's why we have this. And if we're going to multiply 1 times this one, it's just cosine x minus pi over 2. Since we're able to solve or get the derivative of the numerator and the denominator, it's ready, or we are ready to solve for the limits of the of the function. So we're gonna do limits. Oh, red is actually not a good thing. So let me change the color into, let's say, green. Okay, green along. So let's take the limits of the derivative of the numerator, which is -2. So we're gonna do -2 here over the limit of the derivative of the denominator, which is this one, just the cosine x minus pi over 2 as x approaches to pi over 2 still. All right, so limit of the numerator, remember that limit of a constant is just the constant itself. So we just have to copy -2. And to evaluate this limit here, you just have to substitute pi over 2 here as your x. So that's going to become cosine times, oh sorry, cosine pi over 2 over pi over 2. It's not times, it's just one term because you can't write a trigonometric term without anything here. So it has to have a theta term here. So here, -2 over cosine 0, right? And cosine 0, guys, is actually 1. You can still use your calculator to evaluate that. So what will happen here, what? We have -2 over 1, or simply -2. So our answer here is this one. The limit, the limit of the given, original given, which is this one, is technically equal to -2. Oh, I hope this helps to those people who are struggling in basic calculus to evaluate the limit. So the clue there is you do a test first, and if you're going to get indeterminate form, which is 0 over 0, that's when the time you apply the L'Hopital's rule, take the derivative of the numerator and derivative of the denominator, and then evaluate the limit. That's it. Thank you.